Resonance is another technique that we can use with Lewis structures. The idea of resonance is that sometimes I can make more than one possible Lewis structure for a given chemical formula. If I have two structures for the same molecule and both follow the rules, they both have the right total number of electrons, they both have complete octets or sometimes even expanded octets if it's a group 3 or higher, period 3 or higher. And if I can make more than one structure, we call them resonance structures. We're going to draw all the possible structures we can and use double-headed arrows to sort of indicate that these are resonance structures. So when you see this double-headed arrow between two different structures, that's suggesting that they're resonance structures. It's the same molecule but drawn in different ways. In reality, we found this true from doing experimental observations, spectroscopy and such, that the true structure, this is sulfur dioxide, and we see that it exists in these two forms. And the true structure is actually something in between these two. When we measure, we can measure bond lengths of the sulfur-oxygen bond. And here I have a double bond, here I have a single bond. When we measure this, it turns out the bond length is in between a single and a double bond for both of these, suggesting that it's sort of a overall picture of some of these. We will find, though, that sometimes I can draw several resonance structures, but not all resonance structures are the preferred resonance structure. We're going to be practicing how to evaluate a resonance structure to see if it's a very stable, if it's the best possible resonance structure. And so they may not be equally contributing to the overall picture of what that is. In this case, these end up being very similar. So again, how do I know it's a resonance structure? We'll see it, but basically when we get to a point where we need to make, they almost always involve double bonds. And when we get to a point where we need to make it, if I have more than one option of where I draw them, that suggests that I could try it a variety of different ways and make different resonance structures. And again, to be resonance structures, the atoms must be in the same place. The only difference is the bonding in the lone pair. So I set an arrangement, in this case with a sulfur in the middle and an oxygen on the left and an oxygen on the right, and then I don't move the chemical symbols. I just move the bonds and the lone pairs. That would be resonance structures. How would I make them? So sometimes we recognize that center atom doesn't have a complete octet. We put our electrons, our lone pair electrons on the outer atoms, and we run out. And we see when we check for octet that that center atom is not a complete octet. So we know it needs more electrons. We'll usually form a double bond by taking a lone pair from an outer atom and turning it into a double bond, or maybe even a triple bond. If there's more than one option of how I could accomplish that, each option becomes a resonance structure. Sometimes also, if I'm given a starting structure, I can form additional resonance structures by moving electron pairs. I say, oh, let me move this lone pair between the atoms to form a double or triple bond. Or sometimes in organic chemistry, we'll see you take a double or triple bond and move it to be a lone pair. So I can kind of move stuff around and then evaluate, is this a better structure? We'll see how to evaluate structures in the next section. You already drew one Lewis structure for XeO3, xenon with 3 oxygens. There are 8 resonance structures. So now that you have that first one, try to figure out, well, what would be different possibilities that you could do for moving lone pairs and turning them into double or triple bonds, or taking double or triple bonds and moving them into lone pairs. Let's see if you can come up with all 8.